There is a category of planning failure that emerges from the perfect execution of a plan that should never have been conceived. An institution designs something to serve a specific purpose, designs it correctly, builds it properly, and then discovers that the design was so good at doing what it was asked to do that it prevents the actual purpose from being served. These are uncommon situations because they require a specific combination of over-specification and over-achievement. The kind of thing that happens when the people doing the actual work apply their full capabilities to a brief that was written by people who understood what they wanted in theory but not in practice. The locomotive that experienced this particular form of failure was designed in the aftermath of the Second World War by the British Railways as a training machine. The context was the reconstruction of the railway system after 6 years of war that had consumed resources and worn out equipment at a rate that created massive maintenance challenges and a corresponding need for trained personnel capable of understanding what the machines required. The railway companies recognized that they needed more fitters, more mechanics, more men who understood locomotive engineering at a level deeper than rote procedure could provide. They needed, in other words, learning opportunities of a kind that would permit young men to encounter real problems and work through solutions under the supervision of experienced craftsmen who could guide them toward proper understanding. The traditional approach to apprentice training on railways had always involved assigning trainees to locomotives under the supervision of experienced fitters who would point out problems and guide the apprentices through the process of addressing them. The method worked, but it had a significant limitation. It depended on the locomotives developing problems. An apprentice could not be taught the diagnosis and repair of a worn bearing if the bearing was not worn. A trainee could not learn to identify and correct a boiler condition that was emerging if the boiler was not in a state that required such intervention. The training process was, in essence, opportunistic. It happened when the machines developed problems, and some machines developed problems faster than others, and some machines developed problems in ways that were more instructive than others. In the post-war period, faced with the need to accelerate the training of apprentices and to ensure that training coverage was comprehensive rather than dependent on the random emergence of instructive failures, the railway companies decided to take a different approach. They would commission a locomotive specifically designed to be used for training purposes. The locomotive would be constructed in such a way that it would develop problems in a controlled and predictable manner. It would break in ways that were instructive. It would require maintenance intervention on a schedule that aligned with the curriculum of the apprenticeship program rather than on the schedule that actual operational need would impose. The design brief was explicit about this. The training locomotive should be built in such a way that it would require regular overhauls of specific systems, that components would wear in patterns that would expose apprentices to the full range of maintenance procedures, that problems would emerge with sufficient frequency to provide learning opportunities throughout the training period. The locomotive should be robust enough to withstand use by trainees working under supervision, but not so robust that it became reliable. It should be constructed in such a way that it would develop problems, and specifically, the kinds of problems that a well-designed apprenticeship curriculum could build around. The engineer assigned to this project was a man named Geoffrey Chandler, who had spent 20 years at one of the major locomotive works and who was brought into the railway company's engineering department specifically to head the post-war reconstruction and training initiatives. Chandler understood the technical requirements of the brief. He also understood, in a way that was not explicitly stated in the brief, but that he inferred from context, that the railway company wanted a machine that would be reliable enough to be safe for trainees to work on, while being unreliable enough to be educationally valuable. What Chandler produced was a design that met every specification that had been explicitly stated in the brief. It was a 060 saddle tank, a small shunting engine of a type that was commonly used for training purposes because its size made it manageable for young men to work on, and its systems were simple enough to be comprehensible without requiring expert knowledge. The boiler was designed to be robust, but the feed water system was specified with tolerances that would result in scaling and the kinds of boiler conditions that required periodic attention. The valve gear was designed with bearing surfaces that would wear at a predictable rate under training use, requiring adjustment and eventual replacement on a schedule that aligned with the apprenticeship program. The locomotive was built at a major works and completed in 1947. It was delivered to the training establishment that had been set up at one of the major depots, positioned on a section of track where trainees would work on it under the supervision of experienced fitters, and made ready for its purpose. What happened in the first months of operation revealed the limits of the engineering brief's correspondence with what the brief's authors actually wanted. The locomotive was built properly. It was built according to specification, and it was built so well that the problems it was supposed to develop in a controlled and predictable manner simply did not emerge with the frequency or in the patterns that Chandler's design had theoretically predicted. The boiler scaling that was supposed to require regular attention and provide learning opportunities for apprentices was less severe than expected. The valve gear bearing wear that was supposed to require adjustment on a schedule aligned with the apprenticeship curriculum happened more slowly than the design calculations had suggested. The other systems of the locomotive, constructed to the standards that Chandler had applied throughout his career, simply worked better than the brief had intended them to work. The result was a training locomotive that was too reliable. It developed problems, yes, but not with sufficient frequency or in the pattern that the training curriculum had been designed to accommodate. Apprentices were assigned to work on it, but there was often nothing that needed doing. Experienced fitters found themselves explaining to young men who were supposed to be learning through doing that this particular piece of equipment was currently in acceptable condition and would not be receiving attention at this time. The response from the training department was not satisfaction, but frustration. They had commissioned a machine designed to teach. The machine was teaching them, but not in the way they had expected. Instead of teaching through the controlled emergence of instructive problems, the locomotive was teaching through the absence of those problems, demonstrating to apprentices that a properly built and properly maintained machine could operate reliably without the constant intervention that the training curriculum had assumed would be necessary. The railway company's response was to continue operating the locomotive for training purposes while using other, older and less reliable machines for the actual instruction of apprentices. A locomotive that had been built specifically to provide training value was placed in service as a utility shunting engine because it was too good at what it was supposed to do to be useful for what it was supposed to do it for. The irony was complete and fairly obvious to anyone who stopped to think about it. But nobody in the organization seemed inclined to stop and think. The training locomotive, as it continued to be called despite no longer being used for training, worked as a reliable shunting engine throughout its career. It developed minor problems from time to time, the kinds of problems that any locomotive encounters through age and use, and these problems were addressed in the normal course of maintenance. It was well maintained because it was being used as a utility engine, and the organization had resources for maintaining utility engines. It was never driven hard because shunting work does not demand the sustained effort that express passenger service requires. It was never subjected to the abuse that an overworked locomotive experiences because the depot had other machines for work that demanded such abuse. The result was a locomotive that became one of the most reliable engines at the facility, an outcome so completely contrary to what it had been designed to be that the engineering department, which had other concerns after the post-war reconstruction period ended, simply stopped paying attention to the matter. The locomotive continued working into the 1960s, by which time the whole issue of its design and intended purpose had become a matter that nobody in the organization had experienced directly. The men who had commissioned it were retired. The engineer who had designed it was retired. The training department that had intended to use it had reorganized around different priorities. The locomotive was simply a machine that was there, that worked, that had a job to do, and that did that job without particular distinction. It was retired from service in 1967 and scrapped in 1968, with no particular attention being paid to the fact that it was the last surviving machine from the training initiative of the post-war period. Nobody in the scrapyard knew what it had been designed for. Nobody in the railway company noted its departure. Nobody thought to preserve it as an example of a training machine or a monument to the post-war reconstruction effort. What survived was the design file still present in the railway company's archive, decades after the locomotive itself had been melted down. When a railway historian examining the post-war reconstruction records came across the original design brief with its explicit statement that the locomotive should be designed to develop problems in a controlled pattern, and then came across the subsequent notes about its actual performance, and then came across the documentation of how it had been reassigned to utility work because it was too reliable to be useful for training, the ironies became apparent. The locomotive had been built for a specific purpose. It had been too good at being built to serve that purpose. The story of the training locomotive that was too reliable reveals something about the gap between intention and outcome that is particularly evident in organizational thinking. The railway company had understood that it needed a training machine. It had specified what a training machine should do. The engineer had designed a machine that would do those things. But the engineer had built the machine to the standards that all his experience had taught him were correct standards. He had built it well. And in building it well, he had made it unsuitable for the specific purpose it had been designed for, because that purpose required the machine to fail in particular ways, and the machine refused to fail in those ways. The training locomotive was not unique in this regard. Organizations regularly commission things that are then found to be unsuitable for their intended purpose, because they were built too well, because they worked too reliably, because the people who built them applied their full capability to the task without reservation. The response is usually to use them for something else, which is what happened to the training locomotive. The locomotive was reassigned. The problem was solved. The irony was left in place, and nobody thought much about it afterward. But the irony remains. A locomotive built to teach through controlled failure became useful precisely because it refused to fail. A machine designed to be instructive in its problems became instructive instead through its lack of problems, teaching a lesson that nobody had intended to teach, which is that sometimes excellence is its own kind of obstacle, that sometimes being too good at something prevents you from serving the specific purpose you were designed for, and that the solution is generally to find another purpose that your excellence can serve, rather than to degrade you until you are bad enough to serve the original purpose. The training locomotive that was too reliable to be useful for training still exists in the historical record, preserved in the files of a railway company as a monument to a design that was over-specified and executed too well. It is a reminder that engineering excellence and institutional purpose do not always align, that building something properly and building something for a specific purpose are not always the same thing, and that sometimes the finest achievement is to build something so well that it becomes unsuitable for what it was commissioned to do.